Hello students. So yesterday we saw questions from basics of arithmetic from 2023 and 2022, and today we shall continue same thing for 3 years prior to that, that is 2021, 2020 and 2019. And here we are covering all the questions from topics like number systems, then mathematical operations, that is addition, multiplication, subtraction, division, and then we are covering from exponents or powers, fractions, HCF, LCM and prime factorization. There are some other topics that are remaining that we shall cover tomorrow for all the 5 years. But let us continue for these particular topics, questions from 2021 to 2019. Now look at this question. We have to consider all 3 digits number, and how do we consider? Without repetition, that is given, without repetition of digits, obtained using 3 non-zero digits which are multiples of 3, and let S be their sum. So there is some sum of some numbers. Which are these numbers? These are 3-digit numbers formed out of these digits that are non-zero and multiples of 3. Which are the non-zero digits that are multiples of 3? 3, 6 and 9. These are the only 3. And we have to form numbers like this, 3-digit numbers like this, where there is no repetition is allowed. So how many numbers are possible? We can simply see that. Let us first fix 3, then what else? 3, 9, 6, then 6, 3, 9, 6, 9, 3, 9, 3, 6, 9, 6, 3. These are all the digits possible. These are all the 3-digit numbers that are possible from 3, 6, 9, such that there is no repetition, and S is their sum. We can just add all of them. What is the addition? You can see 3 plus 6, 9, 9 plus 9, 18, and 18 plus 18 is 36. We are carrying forward 3, again 36 plus 3, 39, carrying forward 3, and 36 plus 3, 39. So we have value of S. And now there are 2 statements. Statement 1 is S is always divisible by 74. We can just check. And second is S is divisible by 9. We can just check. 9 you can simply check. Divisibility test of 9. I am sure you will be familiar with it, that sum of the digits should be divisible by 9. Now what is the sum of digits? 9 plus 9, 18. 18 plus 6, 24 plus 3, 27. Because 27 is divisible by 9. This statement is correct. S is always divisible by 9. That is true. And this you have to check. Now, of course, you are nobody would be familiar with table of 74, but you can write 74 as 2 into 37 prime factorization. Now this is divisible by 2. Yes, of course. Now we just have to check if this number is divisible by 37. That you have to check. There is no alternative to it. We have to perform the long division. We have to divide this 3996 by 37, but it is not such a difficult task. You can see 37 ones are 37. You subtract 37, you get 296, and you can see that 37 into what will it be? 8, I think. 37 into 8 is 296 in fact, and you get remainder as 0, and this is also true. So this number is indeed divisible by 74 and 9. That was all that was required to do in this question. We just have to deconstruct the language in which question is given. Question in itself is not a challenge, but language perhaps could be challenge to many of you if you are not having that familiarity with the language, or you don't have that kind of concentration or patience to understand. Just consider, just be patient to understand the language and try to write whatever that whatever there is given in the question. All that was given is we have 3 numbers which are multiples of 3, that are 3, 6 and 9. These are 3 digits, and we have to form numbers out of these such that no repetition is there. So one number can be only used once, and we form all the possibilities. We add them and just check which of these statements are correct. This was very doable even within the examination hall. Now let us see the next question. Next question again is conceptually very easy. I mean, there is nothing really in it. You just have to check the divisibility. And how do we check? We just check the divisibility by actually dividing. We want this particular number to be divisible by 7, and we have to choose a digit here p such that it happens. So we just try. We actually divide 1, 2, 5, p, 3 and 6 and 9. We divide by 7. Let us see till where we can go using just p. We can have 5. One. I am writing it here. What would be the next digit after 2? We have 5. And then we get your p. Now what this p is, depending on that we'll have the next number in the quotient and next number in the subtraction. What can it be? It can be either 7 3s or 7 4s, right? If it is 7 3s, we can have p as anything, but what happens after that? So whatever we get, we have to ensure that there is complete divisibility. So this number, and we have whatever is here, then next digit is 3. Then we have to subtract whatever is here, next digit is 6. Whatever is here, next digit is 9. And here in the table of 7, where do we get last digit as 9? Because this 9 is the last digit. It is only happening at the 49. So it has to be 49. So this digit has to be 4, right? It has to be 49. Now what can we do? Here, here and here there is 7. 7 sevens are 49, and that is the ultimate subtraction, and we get remainder as 0. Now before we get 9, we have to subtract something for this number, and you get remainder as 4, right? So here you have to have 2. Where do you get last digit 2 in the table of 7? It happens in 42, right? So you get 6 here, and because this is remainder as 4, it has to be 46. Now again you get 4 here, so you have to get 9 here, so that 13 minus 9 you get 4, right? And where do we get 9? You get in 49, so it has to be 7, and because this is 49, this has to be 5, so that subtraction is 4. And then because this is 5, then 20 something minus this multiple of 7, you get 5. What could be multiple of 7? It cannot be 28, because then this had to be 33, which is not true. So it has to be 21, and something minus 21 is 5, something has to be 26. Answer here is 6. Conceptually this was nothing but long division. I know many of you might face difficulty in actually performing this in examination condition. So what you might want to do is trial and error. Matlab, come till here there is no doubt till here, and then you can write this 2 and take the next digit as 1, try it out, take next digit as 6, try it out, take next digit as 7, try it out, take next digit as p as 9, and complete the division. Wherever you get remainder 0, that is your answer. Simple, right? That I think everyone can do, even in examination hall. But because till this step there is just long division that has to be performed, that I am sure every one of you can do. And from here you can just put values for p. It will be little bit time consuming, but even this reverse engineering is that much time consuming. So either way is fine, but you should get the same answer. I hope what I said was correct, that till here we arrived like we always do, but Then because we were not sure what p was, we tried to reverse engineer from bottom to top using same principles of long division. Mathematically there is no challenge. The challenge was of time, but again it is worth if you can get assured 2.5 marks. Now this is the question which was meant to be done from options. There is no other alternative, because the question says there is a certain number. We don't know anything about that number. Only thing is, when we multiply by 7, when we multiply that number by 7, we get only 1, 1, 1, 1, 1, 1. We don't have any information about that number. So obviously we have to go from option, because we have no other information. And what do? You just have to multiply each of these number by 7. That is what you have to do. There is no other alternative. There is no shortcut. If you are lucky, you will arrive at the number first. Otherwise, you may have to perform few more multiplication. You just have to multiply this number by 7 and check. 7 3s are 21. So 1 has to come. So units place has to be 3. So everywhere it is 3. Everywhere it is 1. And carry forward is 2. Next is 7 1s are 7 plus 2, 9. That is not allowed. 7 2s are 14 plus 2, 16. 6 is not allowed. 7 8s are 56 plus 2, 58. 8 is not allowed. 7 7s are 49 plus 2, 51. So this should be the answer. You just have to perform multiplication, and only condition is, when we multiply any of these number by 7, all you should get is 1 1 1 1 1 1. And even if you perform last 2 digits, you can easily arrive at the answer as option number D. Let us see the next question. Again, in 2020 there were a lot of questions from this particular topic, and in 2023 there were a lot of questions from this particular arithmetic chapter. So it has been different. Sometimes there are more questions, sometimes there are less questions from that particular chapter. So as a student, all we can do is we ensure that we are thorough with multiple chapters, so that any chapter they ask question on, we should not be unfazed. We should be unfazed rather. We should not get impacted or demoralized in the examination hall. That is something that is in our hands. But in any case, even if direct questions are not asked, indirect questions are invariably asked from arithmetic chapter in the form of data sufficiency, or in some other way, in the form of some LR questions are mixed with arithmetic. So such questions are always asked. Arithmetic is always important. Let us see this next question. Again we have this 3-digit number, and what is given is that this x plus y plus z is not a multiple of 3. That is given. Then this particular number is not a divisible by which of these? That is the question. Because there is symmetry, and this question has unknowns like x, y, z, 3-digit number, all the digits are unknown, and there is this sum which is symmetric. So we can definitely think about place values. So we can write x, y, z as 100x plus 10y plus z. We can write y, zx as 100y plus 10z plus x, and you can write z x y as 100z plus 10x plus y. And this particular quantity about which we have to comment on, this particular quantity we call it some, let us say s. So this s is equal to, we are just adding, it is just 100 into x plus y plus z plus 10 into x plus y plus z plus x plus y plus z. Very easy, we are just adding. And then because there is x plus y plus z in all the three factors here, we can take it as common, right? So it is x plus y plus z into 100 plus 10 plus 1, which is nothing but x plus y plus z into what is this? 111. Now what is given? S is this, and it is given that this particular x plus y plus z is not a multiple of 3, right? This is not a multiple of 3, so 3 does not divide this particular quantity x plus y plus z. But does 3 divide this quantity 111? Yes, we know, we are aware about divisibility test of 3, that when sum of the digits is divisible by 3, number is divisible by 3. This is definitely, or you can even write it as it. So this is 3 into 37 into x plus y plus z. Now let us look at the options. This particular quantity is that. Is it divisible by 3? Yes, 3 is there. Is it divisible by 37? Definitely. Is it divisible by x plus y plus z? Yes, there is a x plus y plus z in the multiplication. But is it divisible by 9? No, because there is only one times that 3 is occurring. 3 is not here and 3 is not here, that is given. So 3 is only occurring one times. For 9, which is 3 square, 3 has to appear twice, which it is not. That is why answer is B. I hope it was very easy. You just had to write the place values, add them. And what was the hint for using place values? That there is this symmetry and all the digits are unknown. So even if we want to apply any condition, we have to firstly separate x plus y plus z, and to exploit symmetry you have to get some kind of multiples of x plus y plus z. That is why we had to use place values. Again, very easy question. No formulas, no fancy concepts, basic place values used, which we study in our like 4th or 5th class. Okay, let us see the next statement. Next question. We are having two statements and there are two conclusions that are given, and we have to comment on which conclusions follow. This is very easy questions once you understand fundamental concepts of divisibility and prime factorization. First statement is all numbers are divisible by 2. See, here we don't question these particular assumptions. These are given. We have to assume them as true because they are statements. They are not something we have to comment upon. That is given. Okay. So we are given that all numbers are divisible by 2. Okay. So number is divisible by 2. That is given. And all numbers are divisible by 3. That is also given. Now, based on these two statements, can we conclude that all numbers are divisible by 6? When is number divisible by 6? 6 is equal to 2 into 3. That is the prime factorization of 6. So, any number would be divisible by 6 when it is divisible by 2 and when it is divisible by 3. This statement gives us that number is divisible by 2. This gives us that number is divisible by 3. That is why this conclusion is definitely true, because 6 is 2 into 3. Now let us see conclusion number 2. We are having all numbers are divisible by 4. But what is 4? 4 is 2 square. Right? 4 is 2 square. That is the prime factorization of 4. Now when will the number be divisible by 4? When it will be divisible by 2 squared. That is 2 appears 2 times in that particular number. But here we have only once and here we have none. So we cannot comment that if number is divisible by 4, it has to be divisible by number is divisible by 2. We cannot comment. We cannot say that number has to be divisible by 4. For example, 6. 6 is divisible by 2. Yes, but it is not divisible by 4. 10. 10 is divisible by 2. Yes, but 10 is not divisible by 4. That is why this statement or this conclusion does not follow from the given statements. This follows simply from the prime factorization of 4 and concept of divisibility. Very easy. I hope you are finding this useful, or at least you are getting that confidence that this is not something that is not doable or very difficult or out of the ordinary. These are very, very basic questions. The problem is that we somehow have forgotten our basics or basic concepts or fundamental concepts that we learn in our schools, and that is why we are finding it difficult. Yes, there is other factor that knowing the concepts is not enough. You have to be able to apply these concepts in examination conditions. Yes, that is a challenge, and that is why you need practice, that is why you need directed efforts and proper mentoring, and that is why we invite you to join our foundation course ACE CSAT 2024, which is starting from 20th. Anyway, let us get back to the question. The question is, how many integers are there between 1 and 100? Integers we have to comment between 1 and 100, and we have to tell how many, and the condition is they have 4 as a digit, but they are not divisible by 4. Now when is number divisible by 4? When the last 2 digits of the number are divisible by 4, that we know. But anyway, we are talking about here 4 digit numbers. So all we have to do here is count. We don't need anything else. You just need to actually manually count these things. There is no shortcut. You can apply, you can just try to gauge the pattern and you will be through. So we'd want a number that should have 4 as one of the digits, but it should not be divisible by 4. Now starting from 1, we go 1, 2, 3, 4. First time 4 arrives is in the digit 4 itself, is the number 4 itself, but it is divisible by 4, so we don't want that. Then we go 5, 6, 7, 8, 9, 10, no 4. Then next 4 is at 14. Where does 4 arise? 4 arises here, here, then at 24, 34, 44, up till 94. Where else 4 arises? 4 arises here, 41, 42, 43, up till 49, and let us not forget this, 40. These are all the 4s that arise between 1 and 100. There are no other 4s, right? But out of that, we just have to eliminate numbers which are divisible by 4, because that is what they have asked. So we don't want this, we don't want this, we don't want this, we don't want 64, we don't want 84. Rest of them we are fine with. And here we don't want 48. 44 is already cancelled, and we don't want 40 because these are numbers divisible by 4. Now let us just count whatever remains. 14, right? 14, then 34, 54, then we have 74, then we have 94, 5 of those, and then 6, 7, 8, 9, 10, 11 and 12, right? 12 is the answer. Very simple. We have to actually manually count. No need to apply any formulas, no need to look for any fancy theorems or anything. Just manually count them. Now this is very interesting simple questions. That is one of the favorites. I think it has been asked once earlier as well. But all you need to know is the divisibility test of 3. Question is, how many 5-digit prime numbers can be obtained by using all these digits without repetition of digits? Now, if you are aware, I don't know if you are, but in general, finding out prime numbers or checking if the number is prime is a very difficult task. It is not easy to check if the number is prime. You have to go till almost the root of that particular number, even by using calculators and computers, it is a formidable task. So UPSC or anyone will not ask you to manually find all the prime numbers that are 5-digit numbers. It is just not possible. It is not even possible for 3-digit numbers, let alone 5-digit numbers. So ultimately we just have to see pattern, and we have to comment using only logic and no formulas. So we have to look for prime numbers. What is the definition of prime number? Prime number is the number that is divisible by only 1 and itself. That is the prime number. But if you see these digits 1, 2, 3, 4, 5, we don't have to repeat them, that is given. We have to use all of them only once, and we have to form 5-digit numbers. So all of them would be used. So any number using these digits would be something like 2, something like some 2, 3, 1, 4, 5, something, some combination of these same digits. Now what is the sum of digits? Always sum of digits will be 1 plus 2 plus 3 plus 4 plus 5. Sum of digits will always be 15, which is divisible by 3. By divisibility test of 3, which we know that if sum of the digits is divisible by 3, number would be divisible by 3. And because any such 5-digit number out of these digits would be having sum of the digits as 15, because we are using every digit once without repetition, we will always have number divisible by 3. So no such number can be prime, because it has a factor which is not 0 or itself. So how many such numbers are possible? 0. There is no such prime number possible. And as I said, it is not humanly possible that UPSC asks you to actually find prime numbers manually, or 5-digit prime numbers, that too. It is just not possible. Okay. I hope that is clear. Let us come to next question. A digit n greater than 9 is divisible by 3 but not divisible by 6. Okay. Which one of the following is divisible by 4? Now this is not very difficult question. Unfortunately, it is a wrong question because none of the options are actually correct. But we can already, I can tell you how to tackle this type of questions rather than this particular question, because this is a wrong question. A digit greater than 3, it is divisible by 3. Which are the digits that are divisible by 3? Anyway, it is just 0, 3, 6, 9. Out of which we want a digit greater than 3. So this is not allowed, this is not allowed. And it is not divisible by 6. So this is also not allowed. So only 9 we are talking about. Okay. And which of the following is divisible by 4? Okay, sorry. Now just how to compute what are these quantities using n is equal to 9. What is this? This is 18, this is 27, this is 22, this is 28. Question is, which of the following is divisible by 4? Answer is D. Sorry, I was thinking about some other question. This is not wrong. This is in fact correct question because there is unique answer. I was thinking about some other question. My apologies. But anyway, you can understand how to tackle this kind of question. You just have to look for the options, and using options you have to look back. Here there are clear conditions on n, so there is only unique answer. But if in general there is no condition or there are vague conditions, then you can put the values in options to arrive at the answer. Here there are very clear conditions, so answer here is clearly D. This was in fact one of the very easy questions. There is really not much challenge. Now again, next question based on simple divisibility test. We have this 8-digit number, okay, and there is one unknown B here, and it is given that it leaves remainder 0 when divided by 3. What does it mean? That 3 is a factor. This number is divisible by 3. Now we know that from divisibility test of 3 that number is divisible by 3 only when some of the digits are divisible by 3. Now what is sum of the digits? We can just calculate. 4 plus 2 6, 6 plus 5 11, plus 2 13, plus 7 20, plus 4 24, plus 6 30. So we have, this is sum of the digits. We want this to be divisible by 3. So B is a single digit, right? So B can be 0, B can be 3, or B can be 6, or B can be 9. There are 4 options. How many values of B are possible? 4 values of B are possible. Simple. If B is 0, then we will have 30. If B is 3, 33, 36 or 39, all of them are divisible by 3. We just want this number to be divisible by 3 and we are looking for options. Only thing to take care of is don't forget this 0, because that is what mistake would be, that you will tend to forget that you have to add 0 as well. But other than that, very simple question, no real challenge. Only fact you have to use, or only thing you have to know is divisibility test of 3 that we study in our very elementary classes. Now this is again a very simple question that I think 2nd or 3rd standard student can also solve. All you need to know is what is even number and what is odd number. We are given this sequence and we have to say how many odd numbers are followed by the odd number in above sequence. Now there cannot be simpler question than this. We just have to look for odd numbers. This one odd number followed by even, no. Odd number followed by odd number, yes. Odd followed by odd, yes. Then odd, even, then this, then this, then is there one more? First only. So there are in fact 6 such instances. All that we have to check is where is odd number and is it followed by odd number or not. Very, very, very simple question that everybody should have attempted in their examination conditions. Now this is a question from place values, very easy question, and this is very typical of the place value questions. There is a method to do this, and only one extra fact you have to know from linear equations that you have to apply here. Let us see. Firstly, what is given? The given is there a difference between 2-digit number and the number obtained by interchanging its position of digits is 54. So there is a number, some 2-digit number is there, and we reverse it. Okay, if the number is, let's say, xy, we reverse it, we say number is yx, and the difference between these two is given as 54. That is given. Now again, as I already said, that whenever we have unknown digits and the relation is given, some kind of symmetry seems to be there, we can always look for place values. So you can write it as 10x plus y minus 10y plus x is equal to 54. Now I hope you are familiar with this kind of subtraction. This is 10x plus y, because there is minus sign outside, it would be minus 10y, and minus plus minus x is equal to 54. So we have 9x minus 9y is equal to 54. So we have 9 into x minus y is equal to 54. So x minus y is equal to, we can divide by 9 on both sides, we get 6. This is what we get using given condition, that difference between the digits, x and y are digits of this 2-digit number, is 6. Now let us read the first statement, or let us read the second statement rather first. The statement says the difference between the 2 digits of the number can be determined. Yes, definitely, that is what difference between the 2 digits, no? So this statement is absolutely correct. The first statement, let us see, the sum of the 2 digits of the number can be determined only if product of the 2 digits is known. Now firstly, as always, we have to take note of this only. Even in GS, whenever we arrive at, whenever we encounter this only, all, this kind of qualifier, we are always 98% sure that this statement could be false. In this case also, you should be alarmed that there is only used. Okay. Now let us see. We want to comment on sum of the 2 digits of a number can be determined when. That is, sum of the digits is x plus y. We have already x minus y. Okay. We want to comment, or we want to find out rather what is x plus y. Now if we know x and y, we can definitely find out x plus y. But we don't. Why? Because x and y are 2 unknowns. And in equations chapter, we always study that if we have 2 unknowns, we need at least 2 independent equations to solve it. Here only we have 1 equation. So we need 1 more equation to solve it. Now that equation could be anything. Any equation that is different from this equation would do. You give me any equation. Let us, I'm hypothetically creating equation. If I have this 5x plus 4y is equal to some 20. If I have this, I'm not saying this is equation, but if I have this, and with this I can get x and y both the quantities, because we have 2 equations and 2 unknowns, and I can solve for this. Yes. So any equation like x cube into y is equal to some, let us say 8. This is also equation which is different from this. Using these 2 equations also I can find out x and y, and therefore x plus y. So any equation that is different from this equation can help me get values of x and y, and thus x plus y. In general, if we want to find out quantities of if you want to find out two unknowns, we need two equations. If you want to find out n unknowns, we need n independent equations. So it is not necessary that only the product equation is going to work. Of course, product equation is going to work. I mean, if we know this particular equation, so k is some number, then we can find out x and y. That is okay. But can we comment on x plus y only if this equation is given? No, any other equation would also do, which has to be different from x minus y is equal to 6. That is why, because of that only word, this statement is wrong and answer is 2 only. So the fact that you have to use is knowledge of place value system. You just write place values, you put it in the given condition to arrive at one equation. Using that we can answer second part, and for the first part, because there is only word, it turns out as wrong, because any two equations would give us values of these two unknowns. Now let us come to next question. Consider the following addition problem. Now addition is something that we all have studied in our schools. This is addition problem, and question is where these PQR are different digits. Question is, what is the arithmetic mean of all such possible sums? So there could be multiple such possible sums. Question asks us to find out arithmetic mean of all such possible sums. So we have 3p, 4p, pp and pp as RQ2. Let me check if we have correct question or not, because it is possible that there is some yes, this is right. So basically what we have is p plus p plus p plus p should lead to 2 being at the units place. So what can be value of p? P plus p plus p plus p should be 2 at the end. Can p be 1? No. 2? No. 3? Yes. 3 into 4 is 12. So one possible value of p is 3. Can p be 4? No. 4 into 4 is 16. 5? No. 6? No. 7? No. 8? Possible. 9? 9 would be giving us 6 here. And 0? No. So only possibilities for p are 3 and 8. So just let us check. So we have 33 plus 43 plus 33 plus 33, and we have 38 plus 48 plus 88 plus 88. What is this? This is 12. 1 carry forward. This is 142. Yes, P, Q and R. Sorry, P is 3, R is 1 and Q is 4. All are different. That is okay. And then this is 2, this is 3, and we have this is 182. Right? No. 7 plus 3, 10. 10 plus 16, 26. 262. So these are the two possible sums. We have to find out arithmetic mean. Arithmetic mean is what? 142 plus 262 divided by 2, which is nothing but 404 by 2, which is equal to 202. That is the answer. All we have to know is how to add numbers. That is the only skill required. Once you know that, addition of these 4 for p has to give us 2 at the end. So p can be only 3 or 8. Write down p as 3, write down p as 8, find out the sums, add them, divided by 2 to find out arithmetic mean, and we are done. Very easy question. Next question. Now There was question on addition. Now this is question of multiplication and division. Let us see. Consider the following multiplication problem. PQ into 3 is RQQ, where PQR are different digits and R is not 0, that is given. Question is, what is the value of P plus R divided by Q? And there is one more option that it cannot be determined due to insufficient data. Don't be fooled and just mark it and go ahead. Try to solve it, because very often it turns out as this is not the answer, there is answer for the question. So we have PQ into 3 is RQQ. These are all different digits, R is non-zero. Fine. So what can we comment on Q? When Q is such a number that when we multiply it by 3, you should get itself as a units place. And P is such a number that PQ is such a 2-digit number that when we multiply it by 3, we get 3-digit number. So can P be 1? Definitely not, because we have to get, when multiplication by 3, we have to get 3-digit number. Can P be 2? No. Can P be 3? Possible, because after 34 into 3 is 3-digit number. So P cannot be 1 and 2, that we know. P cannot be 1 and 2 because we want to have 3-digit number here. Fine. Now 3 into Q is Q. How many such numbers are there? Let us check. Like we did last question. Can Q be 1? No. Can Q be 0? Let us first start with 0. Can Q be 0? Yes, Q can be 0. Can Q be 1? No. Can Q be 2? No. Can Q be 3? If that is 3 into that number should lead us to that number being at the unit place. That is the condition we are looking for. 3 into 1, 3, we are not getting 1. 3 into 2, 6, we are not getting 2. 3 into 3, 9, we are not getting 3. 3 into 4, 12, we are not getting 4. 3 into 5, 5, that is allowed, right? Q can be 5. 3 into 6, 18, 8, not 6. 3 into 7, 1, not 7. 3 into 8, 4, not 8. 3 into 9, 27 ka 7, not 9. And 3 into 0 already covered. So Q can be only 0 or 5. So we have only two options. P 0 into 3 is equal to R 0 0, or P 5 into 5 is equal to R 5 5. Right. Now when we multiply this 2-digit number by 3, we are getting R 0 0. So this R 0 0 is a multiple of 100, right? This is a multiple of 100 and it is divisible by 3. Because it is multiple of 100 and it is divisible by 3, what can R be? R has to be something like 300, 600, because it is divisible by 3, no? Because we are multiplying by it. So PO, that is what, that is P0 into 3 is equal to R 0 0. So P0 is equal to R 0 0 divided by 3, and this is a integer, not a fraction. So R 0 0 has to be divisible by 3. So R 0 0 can be 300, 600 or 900, something like this, right? But can it be 300? Any 2-digit number into 3, can it be more than 300? No, even if you take 99 into 3, you get 297. R cannot be 3, R has to be 1 or 2, because we are multiplying 2-digit number by 3. So this case, we in fact have to reject what is not, no possible value of R is there. There is only this possibility. Now let us work with that possibility only then. We have P5 into 5 is R 5 5. R can be 1 or 2. R is not 0 and P cannot be 1 or 2. So 5 into 5, 25. You get 2 carried forward. 5 into something plus 2. We need again 5. That is what we are doing. Sorry, this is 3. No. 3 into 5, 15. Carried forward is 1. 3 into p plus 1 has to give us 5 at the end. And so p, when p into 3 has to give us 4 at the end, because that is only when we add 1, you will get 5 here. So can we find out a digit which when multiplied by 3 give us 4 at the end? 1, definitely no. In last question we only did this. There are only 2 digits, 3 and 8. No, not 3 and 8. P into 3 should give us 4 at the end, na? So 1 is not there, 2 is not there, 3 is not possible, 4 no, 5 no, 6 no, 7 no, 8 into 3 is 24, so 4 can be there, so 8 is possibility. 9 no, so only possibility is 8, so P is 8. Now we got the number 8. 5 into 3 is equal to 255. We got our R, we got our P, you got our R, you got our Q. So can we find out this thing? P plus R. P is 8, R is 2 and Q is 5, which is equal to 10 by 5 is equal to 2. I hope you were able to follow the chain of thought that I went through. We have to look for patterns. We have to very patiently do this basic multiplication and addition, because that is where questions are getting asked for last 5 years now, because that is why it is a trend now, and there was culmination of this trend in 2023. That is why we saw many questions which were lengthy due to this fact, but they were not difficult, but they required quite detailed application of all these basic concepts. So I hope it was clear. If not, you can rewatch the video. All we have used is when we multiply Q by 3, you should get Q at the units place. So we found out how many such possibilities are there. Only 2 possibilities came out, that Q was either 5 or 0. So we consider those cases differently, and we rejected the Q as 0 case, because if Q and Q, these are 0 0, then because this R00 has to be multiple of 3, so R has to be 300, 600, something like that, which is not possible, because any 2-digit number multiplied by 3 cannot be more than 300. That is why we rejected that case, and we arrived at Q is equal to 5, and then we worked with Q5 what P can be. Next question. Question is very simple. See, the similar question was asked in 2022. Similar question is being asked in 2020. Question is, how many zeros are at the end of this particular product? Now we know that in decimal system, 0 at the end means power of 10. That is, if we have, let us say this number 1 2 3 4 0 0 0. What does this mean? 1 2 3 4 into 10 raised to 3. So 10 raised to 3 is maximum power of 10 that is available here in this number 1 2 3 4 0 0 0. So similarly, we just have to comment on how many times maximum 10 appears in this particular product. Now what is 10? 10 is equal to 2 into 5. So number of times 10 appears would be determined by number of time 2 appears and number of time 5 appears. Whatever the maximum number of times they appear, they will be tens. So let us calculate how many number of times 5 appears. 5 appears 1, 2, 3, 4. Here it appears twice because 25 is 5 into 5. 6, 7, 8, 9, 10. Here again it appears twice because 50 is 25 into 2. 1 and 1. How many times 5 appear? 4 plus 4, 8 plus 6, 14 times. 14 times 5 appears. 5 appears 14 times. Now if 2 appears at least 14 or more than 14 times, you will have 14 times 10. If 2 appears less than 14 times, let us, for example, if 2 appears only 10 times, then we can get only 10 times 10 because we need both 2 and 5 there. But if 2 appears more than 14 times, let us say 18 times, then we'll have 14 tens here, because then 5 would be the limiting case. Basically we need both 2 and 5 to get a 10. So whatever maximum number of times they appear together, that would be number of times 10 would appear together. So let us see how many times 2 appears. 2 appears 1, here it appears twice because there is 4 here. Here it appears once, here it appears thrice because there is 8 here. Here it appears once, here it appears twice. Does 2 appear anywhere else? You can check. Here it appears twice. No. Here it appears only once. Here it appears thrice because there is 8 here. Here it appears only once. Here it appears twice. Here it appears once. That is all. So how many times 2 appears? 2, 3, 6, 9 and 10 times. So 2 and 5 both has to appear. So lesser of them 10 is the answer. Okay. So basically we have this 2 raised to 10 into 5 raised to 14 into maybe some other numbers, but which is equal to 2 raised to 10 into 5 raised to 10 into 5 raised to 4 into some other numbers, which is equal to 2 into 5 raised to 10 into 5 raised to 4 into some other numbers. This is 10 raised to 10 into 5 raised to 4 into some other number. So 10 maximum times appears is 10. That is why number of zeros is 10. Okay. Next question. Next question, let us see, for what value of n sum of the digits in this number is 2. Now either you can use logic or you can just put various values of n and see the pattern. That is also going to work. 10 raised to some value, 10 raised to some anything value, 10 raised to let us say 1, 10 raised to 2, 10 raised to 3 and so on. What is it? This is 10, this is 100, this is 1000, this is one more 0. So basically any power of 10 would be 1 followed by number of zeros. Always power of 10 would be 1 followed by that many number of zeros. 10 raised to 5 would be 1 followed by 5 zeros. 10 raised to 6 would be 1 followed by 6 zeros and so on. So this 10 raised to n is nothing but 1 followed by n zeros. N could be anything, and plus 1 would just mean that this units place would be 1. And what is this? We want to comment on sum of the digits of this number. What is sum of the digits? This is 1, this is 1, all the rest are 0, so sum of the digits is 2, and that is always true. Question is, for any number. Now again, here the thing is, you have to be aware about these things. Is it true for any positive integer or any whole number or any real number? This is true for any natural number, yes. So basically natural numbers are positive integers, so this is definitely true for positive integers. Is it true for the whole numbers? What is the whole number that is not in positive integers? 0. We just have to check for this. 10 raised to 0 plus 1, which is 1 plus 1, which is 2. So it is true for this as well. So this is true for this is true for this, and this 0 only, that is not true. But for any real number, definitely not, because real numbers involve all the rational numbers as well as irrational numbers, and powers of those 10 raised to rational and irrational numbers, that is simply beyond the course or beyond our understanding. So answer here should be B, and it is B in fact. And if you want to just check, you can check for let us say minus 2. So 10 raised to minus 1, let us say, or minus 2, minus 3, minus 4, minus 1.5, anything could be there, but these numbers will not have sum of the digits as 2. That is the thing. Next question, the point to be noted was that you need to be clear about terminologies. What is natural number, what are positive integers, what is whole number, what is real number, rational number, irrational number, and so on. That terminologies you should be cleared about. Next question. This is from data sufficiency, but in fact it is from prime numbers. All you need to know is prime numbers between 11 and 20. Now let us first read the statements. First statement is n is a prime number. Second statement is n leaves remainder 1 when it is divided by 2. So there are two statements. Okay. Now let us read the question. If n is a unique natural number between 10 and 20, then what is n? So this is given in this part that n is a natural number between 10 and 20, but we just have to tell what is n. We just have to comment on if we can answer this particular question, not find the value of n, but comment on if we can answer this. Now if we use neither of the statements, we cannot comment of course, because there are many natural numbers between 10 and 20. That is, there is 11, 12, 13, 14, 16, 17, all these are natural numbers. So there is no unique answer. So if we use first statement that n is a prime number, if n is a prime number, what are prime numbers between 10 and 20? These are the prime numbers between 10 and 20. So using only first statement, do we have unique answer for the question? No, there are 4 alternatives. Okay. Now let us see only using second statement alone. If you use this alone, that n leaves remainder of 1 when divided by 4. We want to find out number of the type this some 4k plus 1, because we want to have remainder 1 when divided by 4. So we can have 13 and we can have 17. Still we have 2 alternatives using statement 2 alone. But if you use them together, that n is a prime number and it leaves remainder by 2, you still have 2 answers. So even when using both the statements together, we cannot answer this question. So answer is D. Both the statements together are not sufficient to answer this question, because even if you use both the statements together, you have 2 alternatives. Both of these numbers are prime as well as leave remainder 1 when we divide them by 4. That is why answer here is D. And all you need to know here is what are prime numbers between 10 and 20, and what do we mean by when we divide number remainder is this 1. Now this is very elementary question. The only reason I included it here is to tell you that only this kind of questions are the ones that you should look out for and you should attempt on priority. This is very easy type of questions. All you need to do is just put the values in. This means divided by, this means multiplied by, this means minus. Then what is the value of this? 10 star hash is minus 5 at means multiplied by, then $1 means divided by, and 5, right? So this is what you can write it as 10 minus 5 into 1 by 5, right? 5 will get cancelled. 10 minus 1 is 9. Answer is simple. See, the same question which we did yesterday was repeated, just the numbers were different. This is again from the same topic of LCM HCF. Now we want to find what is the least 4-digit number which when divided by 3, 4, 5, 6 gives remainder of 2 in each case. So we have some number, we divided by 3q, then it leaves remainder 2, q1, this is 4, q2 plus 2, 5 q3 plus 3 plus 2, and this is 6 q4 plus 2. So this number x minus 2 is in fact divisible by all the numbers 3, 4, 5 and 6. That is, this number x minus 2 is a multiple of 3, 4, 5 and 6. That is, x minus 2 is a common multiple of all these numbers 3, 4, 5, 6. Where have we heard this term common multiple? In LCM chapter, least common multiple. So we find out LCM of this 3, 4, 5, 6, 3 prime factorization is 3, 4 which is 2 square, 5 is equal to 5, 6 is equal to 2 into 3. So LCM is equal to maximum power of 2, maximum power of 3, maximum power of 5, right? That is all, which is equal to 60. LCM is 60. But we need a 4-digit number. 60 plus 2, we get only to 62. We need a 4-digit number. So we want to find out multiple of 60, which is just more than 1000, because we want 4-digit number. So we take multiples of 50, multiples of 60. You can try it out. So 60 into, let us say 15, you get 900. Yet we are falling short of 1000. 60 into 16, we get 960. Still not crossed 4-digit mark. 60 into 17, 1020. Now we have a 4-digit number. So this x minus 2, which is common multiple of 3, 4, 5, 6, has to be a multiple of 60 as well. And because we want 4-digit number, we looked for multiples of 60 which are 4-digit. And because we also want the least 4-digit number, we stopped at 1020. So x minus 2 is 1020. So x is 1022. Same question which we did yesterday. Now this question is also from the same chapter of LCM. We have this particular Joseph visits club on 5th day, Harsh on 24th day, Sumit on 9th day. If all of them met at the club on Sunday, then which day will it be that all 3 of them will meet again? So this is kind of mixture of calendar and LCM chapter, or arithmetic and calendar. Not very difficult question, because we have to find out LCM, because this is typical question of LCM, that Joseph visits club on 5th day, 10th day, 15th day, and so on. This second guy visits on, Harsh visits on 24th day, 40th day, and so on. So we have to look for when would they again meet. They will again meet when the day would be a common multiple of all these people. 5 visit on 5, 24 and 9th day. How do we find LCM of these things? 5 is equal to 5. I am writing prime factorization. This is 2 cube into 3, and this is 9 is equal to 3 square. So LCM is equal to 2 cube into 3 square into 5, which is 360. So they will meet on 360th day, right? So 360th day, you divide by 7, find out what is the remainder, and go that many days ahead of Sunday. So 360 divided by 7, you get whatever the remainder, 1, 2, 3, 4, and that many days ahead of Sunday would be the answer. This is kind of mixture of 2 chapters. Let us see the next question. We want, again, this is very standard question that keeps appearing. There is a trick to do this, but I will not, as promised, I will not dwell into any tricks or formulas or anything like that. We will just do it using basic logic and basic arithmetic. We have this particular number. Let us write it as x is equal to 1.272727 and so on. We see that this 2727 is repeating. Okay. So I want to basically get rid of this repeated thing so that I can comment on this x. So to get rid of this repeated thing, what I do is I firstly write another number where the same thing is repeated again and again. Basically I write it, because there are only 2 digits that are repeated, I multiply this x by 100. So what do I have here? 127.272727 and so on. So you note that here number after fraction are same. Here also 2727, here also 2727. So if I subtract x from 100x, all these things after decimal point will get cancelled with each other. So I do that. So I write 100x minus x, which is equal to what? 99x equal to 127 minus 1, because this part will be just cancelled. So we have 126. So 99x is equal to 126. So x, which was my original number, is just 126 by 99. But note that that is not in the options, but both the numerator and denominator are divisible by 9. This is also divisible by 9. This is also divisible by 9. You can find the sum of the digits. So if I divide by 9, what do I get? 14 by 11, which is there in the option. Fine. That is the answer. That is the only thing that we have to take note of, that we write a number and we multiply by some power of 10, so that number after decimal point, that whatever the repetitions are there after decimal point, they come same, and then we can subtract. So this was easier question. So let me just extend this particular question little bit for your benefit. So if we have something like this, like 1.2, and then we have 1717 1717. Now you can't just multiply by 100 here or 10 here and get the same repetition, because here it is 2. So what do we do here is, we firstly ensure that after decimal point only things that are repeated come here. So we have here 12.1717. So after decimal point only the repeated things are here, and now we can then multiply this by 100. 100 into 10x is equal to 1217.1717, and so on. Now we can subtract from here this from this. So we have 1000x minus 10x. So 990, no? 1000 minus 10 is 990x is equal to 1217 minus 12. So we have 1205. So x comes out as 1205 divided by 990. Okay, this is how we do. We firstly multiply the given number in such a way that only the part that is repeated appears after decimal point, and then we ensure that we multiply by particular power of 10, so that this repeated part can get cancelled in the next step. See this question again from the place value system. Here we have 2-digit natural number and number formed by reversing it, and we are given the ratio. So as always, because there is number and number by reversing, etc., we write it as xy is equal to 10x plus y and yx is equal to 10y plus x, and we take ratio because that is the condition. So we have 10x plus y divided by 10y plus x is equal to 4 by 7. That is what is given. So it implies, cross multiplying, we get 7 into 10x plus y is equal to 4 into 10y plus x, which implies 70x plus 7y is equal to 40y plus 4x, which gives us 66x is equal to 33y, which implies 2x is equal to y. This is the condition that we arrive at using given condition. And now the question is, how many such numbers are possible? So anyway, we know that this x and y are digits. So if we have x is equal to 1, then we get y is equal to 2. If we have x is equal to 2, then y is equal to 4. X is equal to 3, y is equal to 6, x is equal to 4, y is equal to 8. But x cannot be equal to 5, because then y becomes a 2-digit number. But we want y as a single digit number. That is why these are the only 4 possibilities. Using this condition, we arrive at only these 4 possibilities, which is the answer. Let us look at next question. I think we just have 3 more questions. Okay, we have this number 136 which is added to this particular number, and sum obtained is this 7a3. A and b are integers, that is given. These are digits basically, and it is given that 7a3 is divisible by 3. The only possible value of b is what? That we have to comment. Now what is given? That this 7a3 is exactly divisible by 3. Using divisibility test of 3. What is divisibility test of 3? That sum of the digits should be divisible by 3. What is sum of the digits? This is 10 plus a. For it to be divisible by 3, a can be 2, a can be 5, a can be 8, right? Now a can be any of those. So, and we have 136 plus 5b3, 5b7 is equal to 7a3. This is the what? This is what we are given. In other words, what we can write is 7a3 minus 136 is equal to 5b3, right? Because we are aware about what is a, so we write that, we try to start our operation using that particular thing, and there are only 3 possibilities. Let us just manually find out. We have 723 minus 136, that is possibility number 1. Second is 73756 minus 136, and third is 783 minus 753 minus 136. This is the possibility number 3. And if we take, if we subtract, what do we get here? $587. So B is 5. Here we have 5. Yes. This is 617, and this is, what is this? This is 647. But we want something like 5b3. Here we are getting other numbers. 5b7, not 3, 5b7. So B has to be 8, because in other cases we are getting 6 at the hundreds place, which is not there. So answer is D, 8. Let us see the next question. In a school, every student is assigned a unique number. Okay. Student is a football player if and only if the identification number is divisible by 4. Cricketer if divisible by 6. And if every number from 1 to 100 is assigned to a student, then how many of them play cricket as well as football? Very simple. If the student plays cricket as well as football, then whatever identification number given to that person is also divisible by 4 and 6. When a number is divisible by both 4 and 6, when would that be possible? When number is divisible by 4, which is equal to 2 square, and 6 is equal to 2 and 3. When the number is divisible by both of them, it will also be divisible by their LCM. What is the LCM? 2 square into 3, which is 12. 12 is the LCM. Basically, question is about finding out how many numbers between these 1 and 100 are divisible by 12. Now we can see that they are from 12, 24, 36 to 96. 12 into 1, 12 into 2, 12 into 3 to 12 into 8. How many numbers are there? 8 numbers. Answer is B. 8 such numbers are possible. And the last question for today is that Sita and Geeta go for a swim after gap of every 2 days and every 3 days. If on 1st January both of them went for a swim together, when will they go next? Again, this question is from LCM, but you don't even need that here. You just need to write first few days, because it is very small gaps are given, 2 and 3. So they go 1, both of them go. Sita, Geeta, they both go at 1 and 1. Now Sita will go after 2 days, gap of every 2 days, and Geeta after gap of every 3 days. Sita will go next after gap of 2 days on 3, then on 5, then on 7, and so on. And after 3 days after 4, then 7. When will they go next together? On 7th of January. Very simple. So we come to end of this arithmetic PYQ session number 2. Tomorrow we'll have one more session of arithmetic which will be much shorter. There are some topics like remainder and comparison of powers, etc. PYQs from that we'll cover tomorrow for last 5 years, and I hope this series is helping you. And yes, again I would like to remind you that our new foundation batch is starting from 20th of October. It would be very comprehensive batch which would focus on these all foundational concepts. Of course, because this is a shorter session, I have to rush through, but in classrooms we can at very slow pace, which is comfortable with students, we can ensure that you are comfortable with application of all these tools that we study, or tools that we use, that we study in our class, like in school days even. You have to be able to use it to find out answer very simply using basic concepts, rather than running behind the formulas, because formulas don't work. So I would like, of course, I will also remind you that the discounted price of only rupees 6,000 is applicable only for first 100 student. So hurry up and please don't miss first few lectures, because they are the foundation of our entire course. And you can come for demo as well, and I hope to see most of you in class. And thank you. We'll meet tomorrow.